Hey everybody, in this video we're going to talk about the difference between pass by reference and pass by value. This is a very common thing that people have problems with, and so it's very important that you get this down because it will affect how you trace through code. It will be a question on a quiz and probably on the final exam, or at least on one of the tests, because this is something that's very fundamental to computer science. When you call a method, how does the value get from your calling method to the actual method that you are calling, and what is available? And some of those things may be surprising to you. So the first statement here is that Java and C# are going to work pretty much the same by default, but there's a lot of things that are different that you can do in C# that you can't do in Java. So you're going to see a lot of examples here. Even if you're a C# student or a Java student, it is important to understand both of these methods, because in other languages that you work with, you're going to see examples that are similar to them. So the concepts are important here, even if you are from the other language, so please stick with me. All right, so the first thing to talk about is how does information get passed from one method to another method when you are calling? And so I'm going to pull up this replit that I have over here. And what we have is just a basic Java class, a main class that we would normally have. You have your main method with your public static void main, and all I did was I created a variable called a, and I set it equal to 0, and I printed out the value of a. And as you would expect, what you're going to get as output from that is the 1 colon that I printed, followed by the number 0. So nothing surprising so far. The next thing I did was I created a little method. I called it doStuff1, and it takes in one parameter, which is this x, and then it changes the value of x inside of that method. It returns void, and so the question is, if I call that method, what is the value of my a before and after I call that method? So we're going to do that. We're going to pop down here, and I'm going to comment out my call to doStuff1, and so you can see that I'm passing a, which currently has a value of 0, up to the method. So let's get a few terminologies going here. Down at the bottom here, where I have the cursor currently, or the line that's highlighted, you would say that I'm making a call to the method doStuff1, and you would say I'm passing it one argument, which is a value from the variable a. So I'm passing one argument. That argument happens to be called a, and right now it has a value of 0. Up here in the method header, or in the definition of the method, I specify what it is that I'm expecting to receive in as a set of parameters. The parameters are always going to be in those parentheses up at the top, and so you can see here I'm expecting to take in one parameter. In this method, I'm calling that one parameter x. So the first thing to be aware of is that the a that exists down here in the main, that a does not exist up in doStuff. doStuff has a variable called x, which is a different variable from a. There's a relationship between what happens with a and x, and let's talk about that. So at the moment that this call happens, the current value of a, whatever that might be, is copied, and that's the key word. It is copied into a variable called x up here. This x variable will only exist as long as we're inside of those curly braces, because that's the method body. So x does not exist in main. If I were to try and do a print line of x, I would get a compile error saying that there is no variable x in main. And there never will be unless I create a separate x down there. All right, so my x variable up here is given a copy of the current value of a. So one way to think about this is if we have some memory, and our memory is typically pictured as this large kind of bucket, all right? And down at the very bottom of our large bucket, we have the call to main. And inside of main, we know that we have an a variable, which is currently equal to 0. Now, when I made that call up to doStuff1, effectively what happened in my memory is a new method was added on, and it's called doStuff1, and it has a new variable called x, which is given, as I mentioned, a copy of the current value of a, which right now is 0, so x is also going to be equal to 0. Now, this visually shows you that they are two completely separate variables. The a that we have down in main and the x that we have up in doStuff, they're in completely different chunks of memory, and that's exactly how I want you to visualize it, because that's exactly how it's actually done. This drawing that I have for you, while crude, is a drawing of the stack, or the execution stack. The thing at the bottom is the very beginning of your program, and as each method is called, they get put on top of the stack. When they're completed, they pop off the top of the stack, and we go back to the thing before it. And that's really how code is executed. All right, so let's get to the important part of this. So the a, which is 0, got passed up and copied on top of x. X is now 0, and then inside of this method, I change x equals to 15. So again, what I need you to realize is that that changes up here, and x is now equal to 15 instead of being equal to 0. All right, so the next thing that happens is we're going to move on to the next line in the method doStuff1, which is a closed curly brace, and that signifies the end of this method. When that happens, this method is erased off the top of the stack, and so that x with its value of 15 is gone. There's no way to get it back once the method is over. The x only exists inside of those curly braces because it was created inside a method. So we're now back in our original main program, and the next line of code that's asked to be done is we're supposed to print back out the value of a. So the thing that's a bit surprising here is that a is still going to be 0. When this runs, you're going to see a 0 and a 0. Even though all kinds of stuff may have happened up here to the x, remember the x was a copy. And this is called pass by value. What we did was we passed the value from a up to x. We did whatever we were going to do with x, and then we returned back. But it had no effect on a. I have stressed this a lot, and you're thinking, okay, this all seems very obvious. I promise you in 5 minutes you're going to be confused, because we're going to talk about other ways that this could have happened, and it will work differently. So Java and C#, if I copied this exact code over and changed that print line to a console write line, C# would have worked the exact same way. I would have gotten 0 and 0 because both C# and Java by default pass by value, meaning that a copy of the value is copied over onto the new variable inside of the method when you make a call. All right, so we're going to pop out to the slides and we're going to take a look at a couple of things about the body of the message. And these are just reinforcing what I just said. I promise, stick with me. This is going to get a little bit more detailed here in a moment. So I always need you to think of a method as kind of like a black box, right? It takes in some inputs. It may have some return values. And then the work of what it's doing is inside of there that actually is making the code that's doing whatever the method body is supposed to do. All right, so the header of a method is always going to look like this format. And we've talked a little bit about this in the review, but we're just going to go through it again. You may have some modifiers, which would be public and static in this case. We talked about public in the review section. So public implies that this method can be called by anyone, whether they're inside this object or outside. Static means that this method is dealing in a static sense. We'll talk about static methods in the next lecture, so don't worry about this for now. The int is the return type of this method. This method is going to return one integer for us. The method name, which is whatever it's going to be, it should be descriptive, and then we have our formal parameters is what we call this, or just our parameters. This method is taking in 2 parameters, an x and a y, and then we have the body of the method where we have a return statement because we said it was going to return an int, so therefore we must return an int. When we call this method, the way that it's going to be called is we're going to call the method name and we're going to pass it 2 parameters. Those are called the actual parameters or the arguments that we're passing to the method. So the arguments to this method are 5 and 2. And as I mentioned, what's going to happen is that 5 is going to get copied into the first one and the 2 is going to get copied into the second one, which is the y. So going into this method, we know that x would be equal to 5, y would be equal to 2. It's going to add the 2 of those together, which will produce 7, and then it's going to return an integer of 7, which when this method returns, that value gets stored into whatever you tell it to store it in, which in this case is a variable called result, and it is of type int. They must match. The result type and where you're storing the result must be of the same type. All right, so that's a quick review of how a method gets called. So as I said, when a parameter is being called to a method, there are 3 possible ways that it can be done. Only one of them applies to Java, the other 2 apply to C#. So it can be passed by value, which is the default in both Java and C#, and that's what we've talked about so far. C# has a concept of a reference and also a concept of an out variable that do a specific thing. There is no equivalent for either of those keywords in Java, but you still need to understand what they are, even if you're a Java student, because you will see them in other languages. Okay, so let's take this example, which is very similar to what I did before. So you have your public static main, you have int a equals 42, we print it out, we see 42, we call method b, there's method b up there, it takes x and it adds 9 to it and it prints it out. So 42 is going to get copied up to x is currently 42, 42 plus 9 is about 51, so when that prints you're going to get a 51. When that returns, you're going to come back down here and move on to the next line. And when you print A again, you're going to still get 42 because 42 is what A is. It never actually changed. That example is identical to what I did in the Replit window, and now your mind is going to be blown. So over in C#, and again, only in C# can you do this, we're going to add one word ahead of the parameter and also the argument. And that word is the ref word, which means we are passing a reference to the number or to the variable instead of passing the value of the variable. Okay, so let's flip through all of this. So a is equal to 42, just like it was, and we do a console.writeLine on a, and we indeed see 42. Life is good, nothing has changed. Now we're going to call b with a reference to a. So what happens here is b gets called, and the x up here and the a down here get connected together. This is because of the keyword ref. What I'm saying is this a and this x are the same thing. So if I go back over to my little drawing here, and I start off at the beginning again, and I draw you another one of these activation stacks, and I stick my main in here, and ooh, that is an N, main. All right, and then we take a look at this. We had an A, and it was equal to 42. Life, the universe, and all. All right, and then we called B. All right, so when we called method B, it has an X variable, which is a referenced A. And what you would basically think of is that they are connected together. All right, I don't copy the value over. I have actually connected the two variables because of the word ref. Okay, so let's see what happens now. So x plus equals 9. Well, in B, what is the value of x? Well, it's 42. So we're going to change the value of x to 51. But you can see what happened here. I followed my little arrow that connected the two bits, and you can see that both x inside of B and also a inside of main are now valid, are equal to 51, which is written so badly I'm going to rewrite it because goodness gracious. All right, so now back over to our code. We console.writeLine x. Well, it looks at what x is, and we can see that x is 51. So it's going to print out 51, and then the kicker is when I come back down here, because they were connected, so the method ended, this went away, but now when I print out A, I also get 51 because it's actually changed. This is an example of passing by reference instead of passing by value. Again, the default in Java and in C# is to pass by value, which means a copy is passed up. However, in C# and only in C#, if you put this word ref on front of any of the parameters and their arguments, you will magically connect the two of them, and now you're passing a reference which allows you to change the original value inside of the method. All right, we're going to talk about the out keyword here just for a moment. Again, this one is specific to C#. The out keyword allows you to have a variable that is only returned from the method. And so that allows you to have a method that returns a value in addition to the main return of the method type. And so here's an example. So we call B, this time with the word out in front of both the parameter list and also in front of the argument list. You'll note that A never got set a value. So when we call B, we come up here, and at this moment in time, x would effectively be equal to 9 because we are setting it equal to 9. At that point, we print and we get 9. When this method ends, the value x is returned out through this parameter to whatever this was. And so a is now equal to 9. So when I print out the console a, I get 9. I will be honest with you, if you're only going to understand one of the two keywords, out is not the one I care the most about. This is a relatively unusual thing. It's worth mentioning because it is possible in C#. This only exists in C#. It does not exist in Java, but it is actually rarely used. The reason it's rarely used is because it's a little bit weird and it's a kind of specific thing to C#. So you will see it in code, but it is not common. All right, so what about more complex data types? What if I were to make a copy of, let's say, an entire object as opposed to passing in just this primitive data type that we were doing earlier? All right, so we're back to dealing with both languages again. This is going to work the same in both languages. So the out and the ref, that part was C# specific. We're back to both languages. All right, so what's happening here is I have a class called dog, and it has exactly one thing in it, which is a public integer called weight. So that is the full definition of the class. And then I have a static method and a main method that I'm going to use that are in my main class, let's say. All right, so we have our normal header, and we start off by creating a new dog. So you should be familiar with this syntax. You have a type, which is dog, and that's going to refer to my class. We're calling the type myDog, and it's going to get a new dog. So we instantiate a dog, boom. And if we look over in memory, effectively what's happened is dog has a weight, there it is there, and weight is set to 0 because a default constructor was called. You don't see it in the definition of the class, but remember, there's always a default constructor, and it will set all variables to their default state, which for an integer is going to be 0. So this creates a variable or an attribute called weight equals 0 that is part of my dog, and I now have a variable called myDog which points to that. Great. So myDog.weight equals 10. All right, cool. So I'm going to take myDog, which is this reference, over to my object, and I'm going to set the weight equal to 10. And we can see, bada bing, weight is now 10. I'm going to print out myDog.weight. No surprise here, that's going to print out 10. Now we're going to do something a little bit more interesting. All right, so we are calling b, which is a method that we have right up here. B is being passed as an argument myDog, which is an object. It's not a primitive type. That's perfectly valid. Up here in my formal parameters, I say dog x. So I'm going to have a dog inside of b called x. All right, so if we look over here, what effectively happened is in that second activation stack, we now have our b, and it points to x. So let me draw this out again for you, just to follow along over here in Enda's terrible drawing land. So we had our main, and inside of our main, we had myDog, and myDog had a weight which was equal to 10. All right, and then we called b as a method. And what b got was an x, which got a copy of the location of myDog. So what I need you to think about is when you're passing an object, not a primitive type, but an object, you are getting a copy of the object, but you're getting a copy of the address of the object in memory. And so where this arrow actually points to is it points to the same object that existed in main. That's really what happened here. When you pass an object into a method, which is what happened here, this is an object because I created an object of type dog, and I'm passing it as an argument into this method, b. What happens is the location of myDog is copied into the location of x. And effectively, as this picture shows, they are both pointing to the same place. So up in my method, when I say x, which is this object that I have up here, dot weight plus equals 9, I'm actually adding to the 9 that was in the main method, because they're both pointed to the same thing. So when I add weight plus 9, the weight for both X and my dog updates to 19. So when I print the weight, you're going to get 19. And when I come down and print my dog's.weight, we're both going to get 19. Now, let me stop for a moment and let me refresh, because what I have just shown you are two examples that are seemingly very different. The first example, I passed a primitive type, an integer. It could have been a float, it could have been a Boolean, it could have been a character, but it was a primitive type. And when I pass a primitive type, a copy of its value is passed up to the method. But when you pass an object, you are getting a copy of the object, but what you're getting is a copy of the location of the object in memory. That's what's being copied. And so when you pass an object, what I need you to think in your head is that the entire object is actually being passed up to the method. And so changes that happen up here actually affect the changes in the main object as well down here. So that's super important. The dog's weight actually changed when we did this. So I'm going to go over to the Replit and I'm going to add in a new class, and the class we're going to do is number.java. I'm just going to basically recreate this example so that you guys have another example. And again, there is nothing magical about this being in Java. This exact code would work in C#. So I'm going to say int num1 equals 7, and I'm going to, just for example, say car1 equals a. All right, so this class just has two things. I'm going to make both of those public because they have to be in order for me to be able to change them. Oops. Wow, what is happening? Okie dokie. And now I'm going to go back into my main method and I'm going to instantiate my number object. So I'm going to say number, my number equals new number. All right, great. So then down here, we are going to print out my number dot car1. Is that what I called it? Car1. Yep, that is what I called it. And what we would expect, I'm just going to get rid of this other code down here, is that if I run this program right now, we're going to see something along the lines of A being printed, because car1, oh, good Lord. All right, public, wow, public JInt. Where did that J come from? I don't know. All right, we're going to see an A because right now car1 is an A. All right, there is my A. Okay, so no surprises so far. I'm going to go back up. Oh, goodness. I'm going to go back up to main, and I'm going to change my method doStuff to take in an object instead of taking in the primitive type. So the object is going to be of type number. I'll leave it being called X, and just to see what happens, I'm going to print out x.car1. And what we would expect is that we're going to see an A from this print statement, and then we're going to see an A from that print statement because, well, regardless of how this was passed, it would have helped if I'd actually called the method, wouldn't it? Regardless of how this was passed, we know that we would see that. So there's my call to my method, and I'm passing it the appropriate object. We're going to see A and A. All right, great. Now, up in my method, I'm going to make a change to the object X. I'm not technically making a change to the object my name, but I am making a change to the object X. I'm going to say x.car1 equals B. And I'm going to come down here and I'm going to print it out again after the method has called. So we're going to see an A from this. It's going to go up. It's going to print out an A from this because that's what it did beforehand. But now what I need you to see is that my number and X have both changed. So when an object is passed into a method, I need you to understand that anything that is changed about that object inside of that method is persistent. Let me say that all again. If an object is passed into a method, anything changed in that object persists after the method is called. That is not true if it is a primitive type. They work quite differently. It is because you're getting a copy of the location of the object as opposed to a copy of the primitive type. All right, I hope that makes sense to you guys. And this would happen regardless of what the method type was. So what happens in what happens in C# if I put the word ref on front of that? Well, some extra weirdness is going to happen in that case. We've modified this code a little bit. So we're going to step through this again. And again, this is useful to understand from the C# method because ref is a word that you can use in C#. It's also interesting from the Java standpoint because there's an important thing that's about to happen here that you're going to see in a second. So dog gets new dog. Dog's weight equals 10. By the way, the dog hasn't changed. It's still got a public weight. So life is good, same as before. We're going to print out the size. We know that that outputs 10, no surprise there. All right, so now things are going to get weird. I'm making a call to B, again, which is my method B up here, but this time I'm passing a reference to my dog. So when I pass a reference, I'm getting a copy. Sorry, I'm not getting a copy of it. I'm actually getting the same object. So X up here gets connected to my dog because of the word ref. Now, here's what's weird. The very first thing I'm going to do up here is I'm going to say X gets new dog. All right, so you'll notice that my X and my dog are the same variable. So when I called X gets new dog up here, what happened is both of them get sent to this new dog that's created up here. And notice that the old dog with weight 10 is down here. So I'm going to say, wait a minute, what's going on with this guy? How do I get back to him? And the answer is, you can't. You have created your first piece of garbage. Garbage happens when you have a piece of memory in your code that you no longer use. Once you're done with it, it goes away. I mean, technically, at the end of each one of your method calls, any variables that were in there are also garbage at that point. They get cleaned up after the method ends. So it's not technically the first piece of garbage you've ever created. You've actually done that quite a bit. So how does this work? What is this garbage and is this a problem? Well, yes and no. The first thing to realize is that both Java and C# have something called a garbage collector. That's literally what it's called. It is a piece of code that runs in the background, and it looks for this exact instance where you have a variable that's occupying some memory that's no longer needed. When it detects that, when it finds something that is garbage, the garbage collector will go through and it will reclaim that block of memory and make it available again for the future. And when I say reclaim it, it basically takes out the trash. It throws that away, and it gives that block of memory back to the available set. Now you might say, why is this necessary? This seems very complex. Well, yes, your computer, of course, has 8 gigs of RAM or 32 gigs of RAM or however much you have, because it turns out RAM is pretty cheap nowadays. And so who cares? This is one integer, and that occupies, 4 bytes or 8 bytes or some very small amount of space. I have gigabytes. Why do I care? Well, one method, one variable sitting out there, you're right, it really doesn't matter. Your code could run all the way through the end before that ever gets picked up, and life would be good. You're not going to run your computer out of memory. But imagine having, the entire phone book of the college campus stored in memory, and then make a copy of it, and then make another copy of it, and then make another copy of it, and have something that's making copies and copies and copies and copies. You can quickly imagine that you could run out of memory. So the garbage collector's role is to stay behind you and pick up after you. It's kind of like that mom that you wish you had in your dorm room, who comes along and cleans up everything nicely after you. You just throw your dirty clothes on the floor, and the garbage collector comes and picks them up for you. That's kind of what's happening in the language. There's both Java and C# have a garbage collector, and it tries to not get in your way. It tries to not be too aggressive, because the garbage collector actually takes some resources. It has to run on the same CPU that your code is running on, and it takes time away from your code. So you don't want it running constantly. You don't want somebody that's nagging you continuously, that's directly behind you picking up everything you do. That would be super annoying. So the garbage collector tries to pace itself and run at just the right speed such that it picks up the things without causing a problem, but make sure that it gives back as much memory as it can. All right, so all this happened because we called new. I sit above the police station and they sometimes test their sirens. We called new on X, and since X is the same as my dog, both X and my dog now point to this new dog. Once that happened, the old dog has nothing pointing to it. There's no way to get there. There's no variable name that is associated with this guy, and so that's why it became garbage. At this point, the garbage collector is going to come along and it's going to get rid of this dog. Because it's an unloved dog, and you should think about what you have done and cry in a corner, because you have made a dog a piece of garbage. But anyway, the important part here is that the garbage collector will clean that up, and you need to be aware that any information that's in here that you wanted is gone the moment that you called new up here. And this would have happened regardless of this ref keyword. This can happen in Java as well. If you call new on a object that you already have, you're getting a new one and the old one is just gone. All right? It just happened here in an example where we were using a ref because, well, this is a good place to talk about this. So this is an important point for both Java and C#. Garbage is a real thing. Garbage will be cleaned up. And if you call new on an object, you will get a new object which will erase the old object effectively. All right, so back to our example. You'll remember that we created a dog, we set its weight to 10, we printed it out, and then we used the ref keyword to pass my dog up to the x. So my dog and x are the same thing. We called new on it, which had the effect of doing this, and now we're setting x.weight equals to 9, so that sets that to 9. If we print out x.weight, we indeed will get 9. And then what happens when we come back out of this method because it's about to end? Well, my dog has been changed. It is now pointed to this 9, not the 10, and the 10 is gone away. So you may be asking yourself, if you have come from some other programming language, is this the same as a pointer? Because there is a pointer in C# and in C, and you'll see pointers in some other languages as well. And there's some very, very similar concepts. You're dealing with a memory address. We don't call them pointers in Java because that's not something that Java really deals in. It tries to abstract away all of these details from you. But effectively, it is a pointer. Can you do primitive types with the ref keyword? Yes, you absolutely can. We saw that in the very beginning. Okay, so let's imagine that I have a piece of code and I actually want to change the value of the variable in a method. Then how do I actually go about doing this? So we're back to working in both languages again. So to be clear, I want to have a method that is, let's say, double. It takes in an integer called x, and it's going to return 2 times x. All right? So we'll call it double it, just so that it's not called double, because double is a type. So that would have been a very bad idea. Now, you can see that that's unhappy immediately because I said it was a void, and in reality, I then tried to return something, and it said you can't do that. So down in my main method here, I'm going to create an int a, and I'm going to set it equal to 2, and I'm going to print it. And just make it pretty. All right, and as we can see, what we're going to get is a equals 2 because, well, that's what I said a equal to. So while that's compiling, I'm just going to go ahead and add in the next line of code. I'm going to call double it, and I'm going to double it, and I'm going to pass it in a. And if I make that call, what is the value of a? Well, it's still 2 because I didn't actually do anything. I just called the method. A got copied up to x, x multiplied by 2, but at the end of the output, so this was my initial print line, a is equal to 2, I then called double it, and when I printed it back out again, a is still equal to 2, nothing has changed. So my double it function isn't really working. If I want my double it function to work, how do I have to do that? Well, when I called double it, I got back an answer. So I'm going to say int b equals that, and I'm going to print out b instead. And what we're now going to see is, of course, a is equal to 2, b is going to be equal to 4 because it successfully doubled it. So if I want to make a change to a variable, then the first choice is I can pass the variable up to a method, I can have the method do whatever it's going to do, and I can have the method return back a value. And that's what happened here. I returned back my answer. So the difference between this and what we have looked at earlier is, in this case, I'm actually returning a value back from the method, and I'm storing it in another variable. Could I have stored it in a? Could I simply say a is equal to double it a and go back to printing out a down here? Well, let's see. Will we get a valid answer? Sure, why not? Why would we not be able to do that? The answer is a will be 2, and then a will suddenly be 4. So I didn't have to make another variable. All right, so this is option number 1. What I did here was I had a method that actually returns back a value to me that is the answer to whatever it is that I was going to do. This will work in both Java and C#. All right, option number 2. I can wrap this variable into an object. Instead of it just being a primitive type that's down here in my main, I can go over to numbers, let's say, and I can say a equals 2 inside of a method. All right, so I have a number inside of an object. I have numbers. It has one public variable called a. I'm going to instantiate that here, so I'm going to say numbers, my a, let's call it, equals new numbers. Great, and then I'm going to print out my a.a. I'm going to do that both times, and I'm going to call my a.a as the method that as the parameter that I'm calling to double it. So up here in double it, I'm going to change this to a void because it's never actually going to have to return anything. What I'm getting in is no longer a primitive type. It is going to be an object called x. And then inside of here, I'm just going to change the value in the object. I'm going to say x.a times equals 2. All right, and we're going to print that. And so before I make the call, we're going to see that that's going to be 2. It's number, not numbers. And I apologize. All right, so before we make the call, we're going to see a 2. After we make the call, we're going to see a 4 because, again, I passed an object up to the method, and then I made a change to the object inside of the method. Yes, all of that is nonsense, and I should have deleted it as I work my way through the compilers. Apologies. So the important part of this is, again, once I pass an object, if I make changes to the object inside of a method, they persist, and I will have the new version. So option number 1, call a method that returns, I did numbers again, good Lord. And I did it twice, so let me fix both of those. Method number 1, I call a method, and I have a return type from the method. That's what I did before this. Option number 2, I wrap the variable in an object, I move the object around, and I do the work on the object, and that will persist. And option number 3, if we are in C#, then I can use the ref keyword in order to make a reference to the same thing, which kind of works like wrapping it in an object. Really? I put a capital. All right, 15th time's a charm, I think. All right. Apologies for the typos here. It's early in the morning, that's my excuse. All right, so you can see that a is 2 and a is now 4 after it comes back because it was wrapped in the object. Let's look at this in C# using the reference keyword. So down here I have x equals 20, y is equal to 30, and I'm making a call to apply it, which I'm passing x and a reference to y. Please note that the ref keyword can be passed on one or more of the parameters. So in this case, I'm only making y a reference, I'm not making x. So up here in my apply it method, I'm taking in an argument of a parameter of a, and I'm taking in a parameter which is a reference called b. I'm doing stuff to calculate a temp, which is a divided by 5. A initially got x, which is 20. So, 20 divided by 2 is 10. So temp is equal to 10. A is equal to b. So a is now going to be equal to 30. And then I'm setting b equals 10 times 5, which is going to be 50. So when I change b, because b is a reference, please note that that is also going to change y down here. So what I'm going to see is my y is going to change at the end of that method. So when I call this and run it, you can see that x started off as 20. Even though I made changes to a up here, I set it right there to some other number. It had no effect because that's not a reference and it's not being returned. But my b, when I changed it, because it's a reference, it actually did get changed down here as the y as well because it's a reference. So hopefully that explains the difference between a reference variable, which is pass by reference, and pass by value. To reiterate one more time, By default, primitive types are going to be passed by value. Objects are going to be passed by value. However, what you're passing is a reference to the object, and therefore, when you make changes to the object, it persists down in the main method. So if you're trying to make changes to a number, you either return it from the method, you pass it as a reference if you're in C#, or you wrap it in an object, and then you pass the object around between the various different things. For most of the time, you're going to do the third of those, which is you're going to put it in an object and pass that around. Okay, so we're going to move on to the next topic in here. No, we're not. That's going to be in a separate video. All right, so this completes our review of pass by reference and pass by value. Hope that helped.